Alright, hello everyone. So today we'll be starting with the linear algebra series. The resources I'll be following are mentioned here. First is Linear Algebra Done Right by Sheldon and the second is Linear Algebra by Gilbert Strang. The first one I'll be following more closely because it studies linear algebra from a much more general point of view. So linear algebra is in general the study of mathematical structures that we call vector spaces, and we'll take a much more general approach to this. So people who may have done a linear algebra course before may have been introduced to matrices, vectors that look like an array of numbers, all those things. So yes, those are also vector spaces provided we define some valid operations for them. But for all intents and purposes, we won't go into specific vector spaces while deriving some important results. But for the application purposes, I will be giving examples of matrices, polynomials, all these things. Alright, so let's just ask ourselves one thing. What exactly is a vector space? Or in fact, what exactly is a vector? So forget the arrow that points in some direction, all those things. For all intents and purposes right now, a vector is anything that can be added together, added with another vector and multiplied with a scalar. Alright, so if we consider V as a collection of vectors, then for all u and v that belong to that collection and any scalar that belongs to, well, the real number or complex number, that is any field, well, u plus v and a times u are valid operations, and in fact, as I'll be mentioning later, they will also be vectors, and if V is a vector space over F, now I'll come to the definition of what is a vector space over F, then u plus v and a times u will also belong to V. It will also belong to the collection of vectors. So if your V is a vector space over F, that is the field, and by field I mean the real number or the set of complex numbers, then the addition operation and the scalar multiplication, they'll be closed. So they'll follow the property of closure. So this V, that is the vector space V, will be closed under this addition and multiplication operation. So I have introduced you to what a vector is, and yes, this is very abstract. I'm not delving into those array of numbers or matrices, because those are introduced and they come with an inherent geometry which not all vector spaces might contain. So just looking at matrices and vectors and those array of numbers that we call as vectors, or any arrow that is floating in space, that is not a generalized notion of a vector. This over here is, and this is what we'll be analyzing and deducing the properties of. So those will be the topics for the later videos in the series. Until then, enjoy and have a nice day. Stay tuned. See you next time.